Okay, here's a merit level skill, and this is where you're asked to solve an equation. Now, if you remember, an equation is where there's an equal sign and something is two expressions equal to there has to be two expressions in it. So one on there's an equals and there's one expression on one side of the equals and another expression on the other side. So in this case we have 3x equals 18. So that is an equation. If it's just an expression, it will look something like this. 2x plus 5 or something. That so it an expression looks like this, whereas an equation has an equals and it is equal to something on the other side. So an equation has an equals. So there's an expression on this side and an expression on this side. Um, that's what an equation is. Whereas an expression is it doesn't have an equals. Okay, it just has an expression. So hopefully that helps a little bit. So when you're working with expressions, usually you're simplifying them and just rewriting them so they're easier. When you're working with equations, you're actually coming up with an answer. And the idea is when we look at an equation, we see there's a variable. So in this case, the variable is c. And we want to solve it so we have an answer where c equals some sort of answer, okay? So we want to find out what does c equal. Now at the moment c minus 4 equals 6. So we know that if I add minus 4 from c, we're going to get the values 6. So the idea is to try and isolate the value of the variable c. So it is on one side of the equals and everything else is on the other side of the equals. So we're going to we move things around so c is by itself. So when I look at this, I've got c and I've got a minus 4. I want c just by itself either on this side of the equals or that side of the equals. Doesn't really matter which side. So I'll put the equals in because we want to keep it there. And I want to move things around so c is isolated. That means by itself. Now to do that, let's just read this. When asked to solve an equation, you are trying to isolate the variable in the question so it's by itself on one side of the equals. And the answer will be on the other side of the equals. Okay, yeah. So reading over here, to solve an equation, you do the opposite operation to the other side. So you do the opposite operation. Now what is the opposite operations we're talking about? We're talking about if we have a plus, we do the opposite to the other side, which is a subtract. If we have a times, we do the opposite to the other side, which is a divide. And if we have a square, remember a square looks like is like this. So this is some sort of power like that squared. On the other side, we do a square root that looks like that, and that will be the opposite. So always do the opposite to the other side. Now there is a little bit more maths behind that, but I'm trying to just make it as simple as possible because when you remember when you divide c divided by c like that, it cancels out, doesn't it? It becomes 1 over 1. That's the same as equal to 1 over 1, like that. We know that, and we just can rewrite it like that. So that's something we learnt in another lesson, that when we divide something by itself, it becomes just equal to 1. And anything times 1 is just the value. So if I go 10 times 1, you notice it doesn't change. It stays as 10. If I go 10 times 1,000, it stays as 1,000. So effectively, dividing anything by itself becomes 1, which means we can ignore it. We just have to know it's 1. When we're moving stuff, we're actually cancelling out. So it's slightly different, okay? So when I've got maybe +2 and I want to cancel out, I'm not going divide by 2. I'm not doing that because that would be 2 divided by 2 equals 1. So I'm not doing the same thing, okay? So don't get confused. I'm doing the opposite operation. So what is the operation? It's plus. So if I go -2, the opposite operation, then it isn't going 2 divided by 2 equals 1. We're not doing that. We're basically making +2 and -2 cancel out. So there's actually 0. Okay, there's 0. It's equal to 0. That there, +2 and -2 cancel out. So 0. So that's the thing you have to really understand. You're trying to eliminate it on one side. Now, think of a scale. I'm going to just draw balancing a seesaw for a second. Okay, so here's a seesaw. It's not a very good seesaw. I can do better than that. Okay, here's a seesaw. It's a terrible seesaw. Okay, here's a balancing like scales. Now, if I've got +2 on this side to something, to have this balanced, I would need +2 on this side, wouldn't I? It's balanced. So +2 is balanced with that +2. And we could say the seesaw is, this pivot point is in equals. Now if I -1, to keep this so it's still like a seesaw and balanced, I'd have to basically -1 to this side as well, wouldn't I? So this is the concept that we're trying to do. If I times this side of the seesaw by 5, then to keep it so it's still equal, I'd have to times this side of the seesaw by 5 as well. Yeah? See how I'm trying to keep the equation that this here is equal to this here. That's the whole part of the equation. Alright, so now you've got the concept of balancing. This is called balancing, where anything I do to this side of the seesaw, I have to do to this side of the seesaw so it doesn't tip one way. It stays equal. Because remember, equals means it has to be equal. Alright, so now you've got the concept of balancing. It should make a little bit of sense that what we're trying to do when we're solving an equation is we're trying to balance it and move things from one side of the seesaw to the other side. So here's what I mean. Here's our seesaw again. We've got our pivot point there, which is our equals. Okay, and this time I've got x plus 2 on this side. Now we don't know what x is, and that's the whole point, is we're trying to find what will x equal. Now on this side I'm going 12. So here's our seesaw. We know that x plus 2 equals 12, and at the moment this here equals this here. It's balanced. Okay, so it's balanced. Now we want x by itself. Now to get rid of that +2 to x, I need to -2. Because now I've got, that would be +2 and -2 would cancel out. That would be like 0. But remember, it would tip this balance if I just -2 to this side and did nothing to this side. Because at the moment, without minusing the 2, it's equal. But if I -2 on this side, I have to what? I have to -2 on this side, don't I? Do the exact opposite. Do exactly the same thing to one side. I have to do to the other side. And so what am I doing? I'm doing the opposite operation. So this is plus and this is minus. Since I've done -2 to this side, so these two cancel out, I have to do minus 2 to this side as well. Because I minus 2 to this side, so I have to minus 2 to this side. So, what have I got? I've got 12 minus 2, and that means it would be equal to 10 on this side. There is nothing, there's no plus 2 anymore, it's just x by itself. So what have I done? I've managed to get x by itself on one side, and the answer to what x must be equal to on the other side. So now I've solved it. X must equal 10. Okay, so by doing the opposite of plus 2 to both sides, it cancelled out. The plus 2 and minus 2 cancel out, so it's 0. And on this side, it is actually tells me, it gives me the answer. Okay, so we're going to do a few what's called one-step equations, where there's only one step you have to do, just so you can get the hang of it and start to see how you do the opposite to the other side. So see how it cancels out. So what is we've got c minus 4. What is the opposite of minus? It's plus. So if I go plus 4 to both sides, after a while you don't have to do plus 4 to both sides. You just realize I just have to do plus 4 to one, the opposite to the other side. Because you don't really need to do this anymore, because you know that if I do the opposite to the other side, I can basically just cancel out that on that side. And now now I've got c by itself, and I've got 6 plus 4, and that means I know that c must equal 10. So what I've done is c minus 4, I just put plus 4 to this side, which gets rid of my minus 4 on this side. And so now I've isolated my variable, so c is by itself. Alright, let's have a look at what's happening with this one here. We've got an x. Our variable is a letter x. And it's saying 3 times x is equal to 18. We want just x by itself. We don't want the 3 times x part. We just want x equals something. So I'll put the equals in, because you always put the equals in and you try and keep it in line. Alright, so we want to have x by itself equal to something on this side. Now what is happening? It's 3 times x. If we go over to our area over here, you'll see that the opposite of x is divide. Yeah, the opposite of times, sorry, is divide. So if I've got 3 times x, I want to do the opposite of 3 times to the other side. And what's the opposite? Is divide. So I'm going to go 18 divided by 3. So I've done the opposite on the other side, because this, remember what's happened here? It's gone 3 divided by 3 equals 1. So that's how we cancel it out. So now we've got, instead of 3 times on this side, we've got 18 divided by 3 on this side, the opposite divide. Now, the answer, we could leave it like this, 18 divided by 3, but if you can do it without having a decimal point, and you can do it like, oh, that's easy, you just divide that by that, and it's not a decimal number, instead of, you go one more step down. But if it becomes a decimal number, just leave it like this. Okay, so 18 divided by 3 is 6, and that means x must equal 6. Yeah, now you can test it to see if it works. You can say, what is 3 times, if 3 times x is 18, and I put x equals 6, I can put 3 times 6, does that equal 18? And if it does, then you know that x must equal 6. So you must have got it right, okay? You can go, yep, got that one right. Okay, so see the opposite? It's 3 times on this side, so I've gone divide by 3 on the other side. Over here, it was minus 4, so I went plus 4 to the other side. Okay, now we've got one where we've got x, our letter, our variable, and it's divided by 5. Now, what's the opposite of divide? Well, let's go over here, and it says the opposite of divide is times. Now, So if I x divided by 5, I need to times both sides by 5. And if you do times 5 to one side, you have to times 5 to the other to balance it, like a seesaw, so it doesn't, you know, doesn't upset the seesaw. So 5 divided by 5 cancels out. It's like 1. And so now we've got x by itself on one side because it's no longer divided by 5 anymore. And you've got 5 times 5, and that means x must equal 25. Of course, you can put 25 there instead of the x and go 25 divided by 5 should equal 5. So they're called one-step problems because basically to get the variable by itself, you only have to do one thing. And that means if it's 3 times, you only have to divide the other side. If it's divide, you have to times the other side. If it's plus, you have to minus, and if it's minus, you have to plus. So they're only one-step problems. Okay, let's move down and let's try two-step. Two-step are more challenging because you've got to do 2 things to get the letter by itself. So I'll use a red pen. Okay, I want b by itself on one side of the equals. So let's try this. Okay, I'm trying my best to line it up, but it's really hard to line up the equals. Okay, so I've got 3 times b plus 2. I'm going to do the opposite of the order of operations. So what's the order of operations normally is times, you do times first and then you do plus last. I'm going to do the opposite. I'm going to do the plus or minus first and then the times or divide second. Okay, I'm going to do the opposite. So I've got 3b plus 2. I'm going to go 3b. I'm going to leave the 3b there. And I'm going to go minus 2, the opposite to the other side. So I'm going to do the opposite to the other side. 24. All right, that's a terrible 24. Minus 2. So the opposite of plus is minus. So I've gone 24 minus 2 to this side, which means my 3b is on one side, and 22 now, 22 is on the other side. Okay, right, so I've done one operation. Now I've got to do another operation. So let's put the equals in so we don't make any mistakes. Now what's the opposite of times? It's divide. So I need to divide 22 on this side, divided by 3. And that means b is equal to 22 divided by 3. That's not going to make a whole number, so I'm going to leave the answer like that, okay? I'm just going to leave it like that. Right, so this is 2 steps. I had to first do one step to get rid of the plus 2 by doing minus 2. And then I had to do another step to get rid of the 3 by doing divide by 3. So I end up with 22 divided by 3 is my answer. Boom. Cool. All right, over here is, so that's a 2-step problem where you have to do 2 steps. But remember, it's only 2, exactly the same as up here as 1-step problems, but you're just doing 1 step in a row. You're just doing 2 of them instead of just 1. Okay, multi-step is where you have to do lots of steps to do it. So this one you have to expand the brackets first. So I have to go 3 times 2x is, 3 times 2x is 6x. Boom, wrong. 6x. Good. And 3 times 3 is 9. 9 equals 27. So my first step when I see a problem with brackets in it like this, either brackets on one side or brackets on both sides, is I would expand the brackets on both sides. On this side, and if there was another brackets on this side, I would expand that. So that would be the first thing I would do. Now that I've got rid of the brackets, and now it's like this, it's actually just a 2-step problem like this one over here, okay? It's the same sort of problem as that one over there, because I got rid of the brackets, so that was 1 step, but now I've got a plus 9 and a times 6 on this side. So there's two things I'm trying to get rid of on this side. So it becomes a two-step problem. So this is just a three-step problem if you think about it. So let's do the order of operations in reverse, and let's do the plus 9. Get rid of the plus 9 first. So to do that, we're going to do the opposite to the other side. So 27 instead of plus 9, we're going to go 27 minus 9. So remember the opposite operation. And that means we're left with 6x by itself. Because we got rid of the plus 9 by doing minus 9. And that's cool. And I'll keep the equals, trying to keep it there. So 27 minus 9 is 18. And my 6 times x is, on this side, I want to do divide by 6 on this side. I want to do the opposite to 6 times. I want to do 6 divide by 6 instead. So now I've left with x, because I did 6 times x, I just did divide by x. And can I simplify that without having a decimals? I can go, yep, that's just 3, isn't it? And that means 18 divided by 6 is 3. That means my answer is x equals 3. See how I'm trying to line up the equals in a row like that and keeping it nice and tidy. Okay, right, let's try this one where we get a variable. There's variables, they're the letters, and they're on both sides. So we've got x on this side and we've got x on this side. We really want x to be isolated to one side. We can't have them on both sides, because then if you move stuff over to that side, it's still got x there. So the first thing you'll do is, when you see letters on both sides, is you have to move the letters to one side. So that way you can get back to moving everything apart. So let's put the equals, try to put the equals there. So what I need to do is I have to move the x's. So I've got 4 x's on this side, and I've got 2 on this side. What I'm going to do is I'm going to move the 2 to this side, okay? You could move the 4 to that side, but it will make it trickier for you later on. So it's easier to go, let's move the plus 2x to that side by minusing 2x. So now we've got 4x minus 2x. So if it's plus 2x on one side, it's now we can move it by going that. So that 2x on that side is now moved to that side. Awesome. And there is actually a minus 6 on there. So we'll leave that. And there is a minus 2 on this side. Okay. Great. Now that means we've got only 2x left. 2x. After doing that, and that minus 6, we can move it to that side by plussing 6. So let's go 6 plus 6 on this side, and there's a minus 2, so we'll just do it that way. So now we've got 6 minus 2 is 4, equals 2 times x. What's the opposite of times? It's divide. So let's divide that side by 2 to get rid of the 2. Oh, we're getting closer. X is by itself. So now you can flick it around now. When it's like this, it doesn't matter which way around you write it. So if I wanted to, I can write x on this side, because it doesn't change it. It doesn't change anything at all, because x is equal to this side and this side is equal to x. So it doesn't matter if you move x to this side and the 4 over 2 to this side. Makes no difference. But if you wanted to, so you usually have the answer on this side equal to that side, okay? So 4 divided by 2 is 2. And you've now managed to get x equal to a number. So that was variables. When you see a letter on both sides, you have to make sure they're all only on one side, and then you solve it by moving. What do? You do the opposite. So if you see a minus 2, you do a plus 2 to the other side, okay? Alright, hopefully you're getting the gist of it. Now there are some harder questions, so we'll try our harder ones, because these divide ones are a little bit more trickier. Okay. When you like this, and it's the divide, what you need to do is you've got to go, this is all divided by 2. So what I need to do is multiply both sides by 4. So let's go multiply that side by 4 and multiply that side by 4. So like that, eh? So now you've multiplied that side by 4. Now, because this is divide by 4, if you multiply that side by 4, it's 4 divided by 4. And they cancel out. That means you're left with, since you times that side by 4, you times that side by 4. So that means you've got 3 times 4 is 12. Awesome. And you've got 3x plus 2 on this side. Oh, this video is getting longer and longer. Alright, on this side. Right, now, once you're at this stage, you realize it's actually quite simple. You just have to move, you just have to basically get rid of the plus 2 to that side. So, easy is just to do this, is to go, okay, I'll minus 2 to that side. So that'll equal 12 minus 2 is 10. So I'm just skipping a step. I'll just write it in so you know what I've done. So cancel that out because I'm minus 2. Now it's 3x equals 10. And I want to divide both sides by 3 so they cancel out. So x is, so 3 times x is, means I'm going to divide by 3 on the other side. By 3. And I could leave it like that. If I had a calculator, I could have a decimal answer, but this would be acceptable in a test, okay? Okay, so there we go. We got rid of divide 1, and it was a multi-step problem. Alright, now you might get one which is a little bit like this, and these look very intimidating, but we'll give it a go. Okay, so when we've got something like this, you can get harder ones than these, but we'll stop. I don't want to get too hard. I want to get rid of the divide by 2 on this side and the divide by 4 on this side. So I'll work on this one first, okay? So it's divide by 2, so what I want to do is multiply the other side by 2. So let's rewrite it. So it's going to be 2 times 5 on this side. Okay, got rid of that by, it's divide by 2, so I times the other side by 2. And this here, divide by 4, I'm going to times the other side by 4. So it's going to be 4 times 4x. Yeah, that times and the x are they get confusing. So that means it's 12x on this side. 4 times 4, 12. Oh, it's 4 times, hang on, no, 4 times 4 is 16. What am I doing? Oops. Just seeing if you're awake, paying attention. Okay. Alright, 16 on one side and 10 on the other side. Awesome. 2 times 5. It's 16 times x, so I want to divide the other side. So 10 divided by 16. Oh, man. And see, that's getting quite messy. We've got an answer. Boom. Done. So it was divide this side, so I times that side. It was divide this side, so I times that side. Okay, here's another one where the letters are on the bottom instead of the top, like here. So to do this one, we do the same thing. We're going to go like this. We're going to go 12 times 2x. 12 times 2x, so basically get rid of that side by timesing that side by 12. And I'm going to go 3x times 3. 3x times, I'm going to use a dot for the times, because otherwise it's getting confusing with the x's and the times. but a dot sometimes means, when it's in the middle, it means times as well. Okay, so 3 times 3x is 9x. 9x equals 24. 12 times 2, 24x. Okay. Whew. All right. So this is this might not be solvable. Okay, because we've got x's on both sides. All right. So I need to divide by 9. Yeah. No, this is becoming very difficult. This is becoming way more difficult. So I'm gonna basically I'm gonna divide the other side by 9. So 24x divided by 9. Yeah, when I was thinking of this problem, yeah, okay. This is, yeah. Unfortunately, because of the way I've written the problem, this problem becomes too hard to solve. Okay, so gonna gonna shift on because it became it's a big issue. Okay, so I'll try and I did it without checking. How about we go oh, I think we'll have to finish it because I'm getting a phone call. Hopefully you've learnt a lot from that video.